Welcome to this explainer. Right now, literally billions of times a second, a hidden sequence of events is firing all across the globe. Today, we're decoding the fascinating, almost instantaneous journey of a simple click, and we'll uncover the completely invisible infrastructure that makes our modern world possible.
I want you to think about your daily routine for a second. Clicking a YouTube video, mashing that like button on Instagram, or doing a quick Google search. We completely expect instantaneous results, right? We just tap the glass on our phones and assume the magic happens. But behind that glass is a massive, highly physical network. We're talking intricate arrays of fiber optic cables crisscrossing oceans, massive data centers humming with activity, and super rigorous standardized protocols that ensure every single bit of data knows exactly where it needs to go.
So, where does that click actually go? Does it just process locally on your phone? Or does it bounce to a cell tower, plunge under the ocean through a fiber optic tube, and hit a server rack in an entirely different country? The reality really challenges our basic assumptions about how local our personal devices actually are, and just how connected every single tap of our fingers is to physical hardware hundreds or even thousands of miles away.
To help decode this invisible loop, here is our roadmap. First, the power of a click. Second, speaking the server's language. Third, the anatomy of a request. Fourth, the restaurant analogy. Fifth, decoding server responses. And finally, completing the conversation loop. Let's dive right in.
All right, section 1, the power of a click. Is it just a button? When you tap your screen, is clicking a button just a local user interface change? Like just some pixels shifting? Well, actually scratch that. That animation, the button depressing or the color changing, is really just a facade. The physical tap is actually the spark that ignites a complex data request sent across the internet. You aren't just changing pixels. You're initiating a highly structured, long-distance data exchange that happens so fast it just feels entirely local.
Moving on to section 2, speaking the server's language. Introducing HTTP.
So, HTTP. It stands for HyperText Transfer Protocol, and it's basically the language that apps use to talk to servers. Invented by Tim Berners-Lee back in 1989, it acts as this invisible, absolutely essential bridge. Think about it. Your browser and a server sitting in Tokyo don't just magically understand each other. They need a shared set of rules. That universal translator is HTTP. Whether your phone is running iOS and the server is running Linux, HTTP ensures they are speaking the exact same grammatical dialect.
Which brings us to section 3, anatomy of a request, translating actions.
Every single click you make translates into a very specific request. When you click Log in and submit a password, you're making what's called a POST request. You're securely bundling your encrypted data into the body, or the payload, of the message to be processed by the server. But on the flip side, if you're just opening up a home page to read the news, you're sending a GET request. You're simply asking the server to fetch and return some data. The actual verb you use changes the entire nature of the transaction.
Let's look at a literal HTTP request line. It looks like this: get/home http/1.1. Let's decode that syntax. Get is the action. It's the verb telling the server, hey, I want data. The /home part is the specific destination page or directory you're looking for. And that http/1.1 at the end, that dictates the precise version of the grammar rules being used, making sure the client and the server can negotiate a flawless exchange without any misinterpretations.
So based on that exact pattern we just learned, what do you think a request for /profile would return? Yeah, exactly. It fetches a user profile. And thanks to these invisible authorization tokens, or session cookies, that your browser automatically attaches to that GET request, the server knows to return your specific profile data, securely isolating it from everyone else's on the network.
Okay, section 4, the restaurant analogy, making it real.
Let's ground all these technical acronyms in a real-world scenario that we all know: ordering food at a restaurant. In this scenario, you are the client, your phone or your laptop. The waiter taking your order, that's the HTTP request, carrying your message. The kitchen in the back is the server processing your order. The time it takes the waiter to walk to the kitchen and come back is your network latency. And finally, the food they bring back to your table, that is the actual data response. Pretty seamless, right?
Next up, section 5, decoding server responses, how servers talk back.
When the kitchen, or rather the server, responds, it includes a status code. HTTP/1.1 200 OK is your ultimate green light. It means complete success. The server understood the request, found the exact resources, and is now handing back what you asked for. And accompanying that 200 OK is the actual payload, usually in the form of HTML code, high-res images, or structured JSON data that your browser instantly compiles to build the web page dynamically.
But then we have the dreaded 404 not found. This is a hard red light. It simply means the requested data is completely missing. Going back to our restaurant analogy, it's like the kitchen is entirely out of the ingredients you ordered. Fun fact here, the 4 at the beginning of 404 specifically categorizes it as a client error. That means the server is actually functioning perfectly, but you, the client, asked for something that simply does not exist.
And finally, we have the 500 server error. Now, unlike the 400 block, a 5 means the problem is firmly, absolutely, on the server's end. Back in the restaurant, this isn't about missing ingredients. This is the kitchen literally catching on fire. The server itself has crashed, run out of memory, or hit a fatal logic bug, and it physically cannot process your request at this time.
I mean, you've almost certainly encountered a 404 error while browsing, right? Every time you click an outdated link, hit a bookmark for a deleted page, or just misspell a URL, you hit a dead end. That is the server politely using its HTTP grammar to tell your browser to stop looking, stop waiting for a data payload, and simply render an error page instead.
Which leads us to our final section, Section 6, completing the conversation loop. The full picture.
Let's tie this entire sequence together. Step 1, your finger clicks. Step 2, that physical action translates into a formatted HTTP request. Step 3, the server receives and processes that payload. Step 4, a response is beamed back. And Step 5, your screen updates. You know what the wildest part of all this is? This entire continuous loop, traveling potentially thousands of miles through fiber optic cables and multiple massive data centers, often happens in under 50 milliseconds. To put that into perspective, that is literally faster than the blink of a human eye. No way, right?
So the key takeaway from this explainer is super simple. Every single click you make is actually a conversation with the server. Next time you double-tap a photo or log into a secure portal, I really want you to think about the incredible, invisible dialogue zipping across oceans and continents just to make it happen. It kind of leaves you wondering, as our devices get faster, data centers get more powerful, and these loops get even tighter, where exactly does human intent end and the network begin? Thanks for joining me on this explainer.